force response of an RL circuit. Now, in the previous class, we have seen what is the response of an RC circuit to a force response. Now, today, we will go through this kind of circuit. This is voltage, very simple, and there is a switch, and there is some resistance into the circuit, and and there is some inductance into the circuit. This kind of circuit we will go through. How will the inductor will store energy into the circuit? What will happen at time t is equal to infinity? Okay, all these things are to be covered today. Now, similar circuit we have already gone through for the RC circuit, and we have seen in the case of RC circuit that the response of this kind of RC circuit is a exponential increasing waveform. So that is the same which we are going for the RL circuit also. Okay. Now we need to what we need to find is what is when the switch is closed at t is equal to 0, and this is the voltage Vs, and this is the R, and this is the N. Okay, so how does this inductor will increase its current? Okay, how the inductor will increase its current, that we want to derive it, and what will be the nature of this response. Okay, now can you tell directly without derivation, or in short, what will be the response of this RL circuit? So from the circuit, as you can see, from this circuit, as you can see that the inductor has a property that L will get short circuit. L will get short circuit at t is equal to infinity. Okay, that means the L which is shown here will be behaving like a short circuit at t is equal to infinity. So obviously this is also a switching circuit. So a switching circuit like this will also have two kind of responses. One is steady state response, and one will be the transient response. Okay. So till now we have seen that transient response of a system is in the form of k times e to the power minus t by tau. Okay. And steady state response is a constant response. Okay, so transient response and steady state response. Now we can write down we need to find what is the expression for current IT in this circuit. So for this circuit, we can write down IT is equal to steady state response. This is similar thing which we have written for RC circuit. Same thing which we are writing for this. Somebody wants to join. People are joining late. So IT is a combination of steady state response plus the transient response. Okay. Now there are two ways which you can find the response of the circuit. One thing is directly you write down the KVL as we have written in the RC circuit. We can write down Vs is equal to Ri plus L di by dt, and then rearrange it and then find the solution which we have already find out in the case of RC circuit. So this approach you already know. This approach is known as differential equation approach. This equation can also be solved through Laplace transformation. So this equation can also be solved through Laplace transformation. Which I think you have gone through in your first year. If not, then you can you will go Laplace transformation in the signal systems course. So you can use the Laplace transformation also for solving this first order differential equation. Very easy. Vs by S is equal to R times Is plus L times S times Is. And what Laplace transformation do? What does Laplace transformation do? It converts your time domain into a frequency domain. And when you go into frequency domain, that is no from time domain to frequency domain, that is known as Laplace transformation, and from frequency domain to time domain, it is known as inverse Laplace transformation. So this equation Vs is equal to Ri plus L di by dt can be solved through Laplace also. Okay, we are solving it through the differential equation approach because by solving through the differential equation approach, we remain only in time domain. However, we can also go for Laplace. It is also a very powerful. Now, for an RL circuit, which was shown earlier, this kind of circuit, we can write directly the response IT is equal to the transient part, okay, the transient part, that is A times e to the power minus t by tau, where tau is equal to L by R, that is the time constant of the circuit, plus the final steady state response. Final steady state response. So can you tell me what will be the, suppose for this circuit which I have drawn in the previous slide, this is a source, this is a switch, this is an R, and this is an L. Okay, so can you tell, suppose the initial inductor current is I 0 is I naught, and this is Vs, and this is R, and the switch is closed at t is equal to 0. So what will be the current which is flowing in this circuit at t is equal to infinity? Quickly, can anybody tell? बताए कोई? What will be the current?
I is equals to Vs by R.
Yes, yes, very good. So I is equal to Vs by R. So that is the steady state. Okay, that is can be written directly just by knowing the property of inductor, because if inductor will get short circuit at t is equal to infinity, similar to the case of capacitor which gets open circuited at t is equal to infinity. So steady state is already known. Steady state is Vs by R. Okay, so that means you can write down IT is equal to, A is a constant. We have not discovered it yet what it is, but we can write IT is equal to A times IT is equal to A times IT is equal to A times e to the power minus t by tau plus Bs by R. Okay, so we can write down IT is equal to A times e to the power minus t by tau plus Bs by R. Okay. Now, one thing you can easily now the initial condition says that suppose initial inductor current is I naught. Suppose, okay, it may be zero also. It may be zero also. For suppose you are switching the circuit for the first time, then it can be zero also. But let us suppose that the initial inductor current is I naught, which was flowing before the switch was closed. So what will happen in that case? In that case, you can put the initial conditions in this equation. So I naught will become at t is equal to 0. So I naught is equal to A plus Vs by R. So A becomes I naught minus Vs by R. Okay, I naught minus Vs by R. So if you put this in again to this equation, you can write down IT is equal to I naught minus Vs by R e to the power minus t by tau plus Vs by R. Okay, so Vs by R is what? This is the final value of current, that is I infinity. What is I naught? This is I0 minus I infinity e to the power minus t by tau plus Vs by R. Okay. So that means the complete expression, that means uh, the complete expression in the case of inductor can also be written like this. इसको ऐसे लिख सकते हैं IT equal to I infinity plus I0 minus I infinity e to the power minus t by tau. Simple. Okay. So this is the governing equation. In the case of capacitor, we have written VCT is equal to V infinity plus V0 minus V infinity to the power minus t by. Only tau is different. Tau is there is L by R. Okay, this you can get directly from the derivation to differential equation. Okay. Now, if this I0 is 0, then you can directly write down at I infinity. If I0 is 0, that means there is no initial inductor current, then you can directly write the current IT is equal to I infinity 1 minus e to the power minus t by tau. No, not but so UT depicts that it is we are operating it at uh, after t greater than t. So the response will be such like that it will be the current will be increasing and then it will be saturated. So that will be the final value of current that is known as Vs by R, and this is the initial value of current at which if it is starting at 0, then this is 0 current, or if it is starting at some initial current, then we can start from here. And then, so for example, if this is I naught and this is Vs by R. Now, as the current is increasing, the voltage, the voltage across the inductor will simultaneously decrease also. So you can depict the voltage decrease like this. Okay, so that will be the voltage across the inductor. This is the current through the inductor, that is IL. Now VL will be something, VL can be find out by different L di by L d by dt of the current expression which you have find. It will come as Vs e to the power minus t by. So the voltage will be decreasing in its nature, and the current will be increasing in its nature. If the switch is turned on at any other time, then you can write down at t minus t1. So all the things we have discussed for this circuit. Okay. So this is very much similar to the case which we have taken for capacitor. Okay, very similar to. Now I request uh, everybody to have some pen paper in your hand, because the next thing which we are going to solve is the numerical. So I am also drawing the numerical. This numerical was asked in GATE 2008 or 9. Okay. This was asked in GATE 2008 and 9. So so many people are joining the class late. Okay. So I request everybody to please solve it. This is based on the concept we have studied till now. So it was asked in GATE 2008 and 9, and transients are very important part of the subject in our objective courses of IES, that is Indian Engineering Services. Now the question is, for a circuit shown here, for example, if this is 100 volt and this is 20 ohm, this is 20 ohm, and there is a switch which is connected here also, and that switch was closed at t is equal to 0, and there is a resistance, 20 ohm resistance, and there is an inductance of 1 Henry. Okay, and then 20 ohm resistance, uh, 20 ohm resistance plus 1 farad of capacitor. So these values of 1 Henry and 1 farad are not practical values, but they are used in the circuits so that the circuits becomes easy for solving out. Otherwise, the practical values may be in millihenry. So this is the circuit. You have 20 ohm resistance, 20 ohm resistance, 20 ohm resistance. You have an inductor. This is an L, and this is a C. Okay, this is a switch. So it becomes a transient. It becomes a switching circuit. Okay, the switch is operated or closed at t is equal to 0. So when the switch is closed at t is equal to 0, the this resistance will not come into the circuit because it will be shorted away. Now find the value of di by dt, and where is I? This is the current I which is flowing in this branch of inductance and resistance. Find the value of di by dt. Find the value of di by dt at t 0 plus. That means you have to find the value of di by dt, that is the change in current through this branch when the switch is just turned on or it is closed at t is equal to 0 plus. Okay. Can you tell the answer after solving this question? 2-3 minutes you can take. So first you have to find out what is happening at t less than 0. Okay. So first find out what is happening at t less than 0. Determine the initial inductor current and initial capacitor voltage and then proceed. So please solve it quickly. Let's see who.
Sir,
Yes, yes.
sir, 5 plus minus 2.5 e power minus 2.5 into e की power 20t minus 20t.
No, no. We want a constant value. The options are constant value is the answer. Options are
Okay, t equal
20
to 0 है
ampere
ना?
per second, 30 ampere per second, 40 ampere per second, and D is 50 ampere per second.
Sir, 50 answer. Fourth.
Okay, your answer is 50. Anybody else? Anybody else who is trying to solve? If you have got an answer, you can unmute your mic, tell your name, and give the answer. कोई और जिसका आया हो? बस एक ही आदमी का आया है?
सर 50 एम्पीयर पर सेकंड।
ओके, ओके, so what is your name who has just given the answer?
सर प्रसून।
Okay, Prasan. Okay, so if you see this circuit, what is happening for t less than 0? For t less than 0, the inductor would be short circuited and the capacitor will be open circuited. The circuit will look like this. I will redraw it. Circuit will look like this. This is 100 volt. This is with resistance 20 ohm. This is another resistance 20 ohm. This is another resistance 20 ohm, and there will be a open circuit. So here it will be a short circuit, and here it will be the open circuit. So we can call it DC 0 minus. Okay. Now, what will be the voltage across the capacitor? Because there is no current flowing here, the voltage will be the voltage which is across the 20 ohm resistance. So IL 0 minus will be equal to 100 upon 20 plus 20. Okay. So that means equal to 2.5 ampere. So that 2.5 ampere current is flowing in this branch. Okay. Then you can calculate VC 0 minus. Okay. So that will be equal to 2.5 into 20, that is 50 volt. Now, once you know that initial capacitor voltage is now 50 volt. Okay. Now, what will happen? कोई कुछ कह रहा है? कोई आवाज? Okay. Anybody who is saying anything? Okay. My screen is not visible. Who is writing? Afifa is writing that my screen is
No,
not
sir, it's
visible.
visible now.
Okay. Okay, you have to just spin it. Okay, otherwise it will be visible. Okay. So once you know the voltage, that is the voltage across these two terminals is 50. Okay. Now next thing which you would uh, need to calculate is, now what will happen for t greater than 0 plus. This is short circuit, that means the resistance will not come away. So at t is equal to 0 plus, we can replace an inductor with a current source, and we can replace a capacitor with a voltage source. Okay, this is only for t is equal to 0 plus. Why we can do it? Because at t is equal to 0 plus, the inductor current cannot change instantaneously, neither the capacitor voltage. So they can be represented by a constant voltage source or a current source. So we can draw it like this: 100 volt, and this is shorted. This is 20, and there will be a current source which is representing inductance. Okay, and 20 ohm, and there is a 50 volt capacitor value. So this is VC naught, and this is I is the current which is flowing, that is 2.5 ampere. So as you can see, the already we have determined what is the voltage across this branch, that is the 20 ohm. So already we are known that it is 50 volt. So this is 50 volt. But in parallel we have a 100 volt source from the source. So if this is 50 volt, then it should also be 50 volt. Okay, and this is 50 volt. This is the capacitor voltage. That is the initial capacitor voltage which we have represented through a DC source. Okay. So now all the things are known. Now simply we can write down VL is equal to L di by dt. Okay. So di by dt will be equal to VL by L. Oh, sorry, VL by L. That is equal to the L is 1, VL is 50. Okay. So this thing you are now knowing. This is the voltage across the inductor, which is we want to know. Okay, so once it is known, this is basically an inductor which is represented by a constant current source. So if this voltage is already known across 20 ohm, so this we already know it is 50 volt. So the next voltage which is there across the inductor at the time of switching, this is the circuit at 0 plus, it should be the 50 volt. So this is 50 by 1, so it will become 50 ampere per second. Okay, this is the concept for solving these types of problems. Okay, fine. Have you understood it?
सर दूसरे मेथड से हो सकता है
हाँ, किसी भी मेथड से हो सकता है, किसी भी
वो
मेथड।
डिफरेंशिएट किया था मैंने इंडक्टर की
कैसे किया था?
तो पहले वो मैंने इंडक्टर करंट निकाला था 2.5 एम्पियर, उसके बाद
यस,
फिर इक्वेशन लिख दी थी I इक्वल टू आई
हाँ,
नॉट
वैसे भी कर सकते हैं, वैसे भी कर सकते हैं, वैसे भी। Okay, this is a more simpler method. Okay, yeah, you need not to write an equation, just you find out what is the voltage across the, because in a complex circuit, this is a simple circuit. In a complex circuit, you may not be able to write the equation correctly, or it may be difficult to write an equation. So quickly you can derive what is the voltage across the inductor just by using the principle that inductor current and capacitor voltage cannot change instantaneously, and then you can find it. Okay. Okay, next question. Next question, which was also asked in GATE 99 or 2000. It was a similar question was also asked in 2002. The question here is: this is a 12-volt battery which is connected to a 2 ohm resistance, and then you have two different capacitances. Okay, this is 0.3 farad and this is 0.6 farad. Okay, and there is a resistance which is in parallel with this. There is a resistance which is in parallel with this, that is 4 ohm. Okay, and this is the voltage V naught across it. So you need to find what is the V naught, the expression for V naught. That is what is the V naught T, how it will change. The expression for V naught you need to find out. So you can assume that switch is here, which is you can say that there is some switch. Let me see where they have placed the switch. So actually, what was there? That actually this was the circuit. That means there was a 12-volt source, 2 ohm resistance, and there were some capacitances. Now, finally, it was connected to this load resistance, 4 ohm load resistance, 4 ohm load resistance, and then we need to find the V naught. What is the V naught? So can you find it? We need to find the expression for V naught.
सर
तो 12
Yes.
e की पावर माइनस टी बाई 0.8
e की पावर -5t/6, 12 e की पावर -5t/6
E to the power
माइनस टी बाई 0.8
-5t/6
and plus something else. So
एक
first you need to find what is the time constant tau of this circuit. First you tell what is tau.
0.12
In fraction, can you tell what is tau? Tau is what?
2 by
4
15.
by 4 by 15.
4/15, sir.
4 by
Tau is 4
15.
by 15.
Yes, sir,
Okay,
4
that is
by
that.
15.
Second. There is another information which I missed. It is also given that BC1, that is, this is C1 and this is C2. The BC1 0 is equal to 20 volt and BC2 0 is equal to 10 volt. This is an additional information. That is, initial capacitor voltages are also there.
पता क्या नहीं है
So we need to find the expression for E greater than equal to 0. That means it will have two parts. One is steady state of forced response and one will be the transient response. So tau can be find out easily if you see from this circuit for t greater than 0. For finding out tau, deactivate. It is just like finding out the Thevenin resistance. Deactivate all independent sources. That means 12 volt will be replaced by its internal resistance. So it will be shorted. So voltage source will be replaced by its internal resistance, which is practically zero. So you can practically short this. So what will happen if you see from this side, the capacitor side, what you will find the 2 ohm and 4 ohm resistances are in parallel. So R equivalent will be equal to 2 in parallel of 4. Okay. So that will be the 2 into 4 divided by 2 plus 4, whatever it will come, 8 divided by 6. Okay. And the C equivalent will be the series combination of both these capacitances. So you know that if the capacitors are connected in series, you can calculate it 0.3 by 0.6 divided by the 0.9. Okay. So when the tau is calculated, then you can calculate the uh, total response of the circuit. So now tau is equal to R equivalent into C equivalent. So R equivalent is known, C equivalent is known, so tau is known. ठीक है, आप कोई बता सकता है आंसर? Anybody would like to tell the answer?
So 12 plus 18 e to the power minus 15 t by 4.
नहीं, ये तो नहीं आ रहा.
Sir, 12 1 minus e to the power minus 15 by 40.
12.
Sir, 12 into 1 minus e to the power minus 15 by 40.
Acha, I am giving you the options. You tell me what is the correct option. So the first option A, which is given in the 8 plus 22 e to the power minus 3.75 t. This is the first option. B is 8 plus 22 e to the power minus t upon 3.75. C is 12 plus 22 e to the power minus 1.2 t. D is 8 plus 22 e to the power minus t by 1.2. So these are the four options. Now you tell which of the options is correct.
Sir, A.
A is correct. और लोग बताएं भाई, किसी ने ये बताया है? क्या नाम है आपका जिसने ये बताया है?
प्रद्युम्न.
हाँ, और भी कोई बताया भाई? प्रद्युम्न सही कह रहे हैं कि नहीं? So the basic equation which we should remember for solving this circuit is the same. VCT is equal to V infinity plus V0 minus V infinity e to the power minus t by theta. Okay. So V0 is already known. That is the, we are not finding here VCT, but we are finding the voltage across the output, that is V0. So V0 T we can also write as V0 infinity plus V, because it will be changing in similar manner as if the capacitor voltage will be changing, the net capacitor voltage, because you see the voltage across the output is a combination of the two capacitor voltage against these two. V0 is equal to VC1 plus VC2. So the variation in C1 and C2 will also be felt at the output side. Okay. So once you write down this basic equation, V naught infinity plus V naught minus V infinity e to the power minus t by tau. So tau is already known. Tau is known. Now what will be V naught infinity? V naught infinity will be, V naught infinity will be when the capacitor will get charged, the V naught will be the voltage across the 4 ohm resistor. So V naught infinity can just find out by the formula 4 upon 6 into 12. So 6 to the 12, this will become 8. The final voltage that will appear across these two capacitances will be 8 volts. Okay, so final, because
Yes,
this,
sir. Yeah.
so the V naught infinity is 8 volt. V naught 0 is already known, that is 30 volt, because it is a combination of VC1 plus VC2. This is already given, this is 20, this is 10, so it will become 30. 30 minus 8, it will become 8 plus 22 e to the power minus 3.75. So at t is equal to infinity, v naught infinity will become 8 volt. So that means the first option is correct. This is correct. Okay. सभी को समझ में आया? Everybody has got it. Okay. Next. Suppose you are having a 10 ohm resistance and you are having a switch which is connected in parallel, and the switch is opened at t is equal to 0. There was some inductance in the circuit. We don't know the value of L, but we know that the current which was flowing earlier was 10 ampere. And there is another switch which is closed at t is equal to 0. And we have a 10 ohm resistance and a capacitor we have that is having initial voltage of 10 volt. Okay. So the question is, find the voltage across inductor and current flowing through capacitor at t is equal to 0 plus. Okay. Please find it. Find the voltage across inductor and the current flowing through capacitor at t is equal to 0 plus. Okay, this is from my side today. Try to solve more numericals. In the coming classes, we will solve more numericals from different books and different competitive examinations. To try to solve this question, the correct answer for it is current current through the capacitor is 4.5 ampere and the voltage across the inductor is 55 volt. This is the answer. I